Hi everyone, my name is Kate Travers. I am very excited to be here today to talk to you about pattern matching, and specifically why I think it's one of the best things to get people excited about both learning Elixir, also teaching it. So, all right, cool. So I'm a software engineer at the Flatiron School. We just opened a campus in London, by the way, so shameless promotion right there. A big part of our mission at Flatiron School is to get people excited about learning new things. Because, let's face it, learning new stuff is hard, like really hard. One example I like to think of is, anyone who's kind of taught themselves a musical instrument, maybe guitar. When you start out, anybody who's excited about learning to play guitar, for example, you're not just toying around. You don't just want to learn a couple chords and call it a day. You're probably learning guitar because you want to be a rock star. You want to be the next David Bowie, because we all want to be David Bowie. So anyway, you're starting out, you have these lofty aspirations. But the problem is, reaching that goal is, you're so far away from that in the beginning. It takes a ton of hard work to get there, and it's really easy to get discouraged. So there's this huge risk of you just completely kind of falling off, dropping the ball, never realizing that dream. So what you need is something to keep you in it, something to keep you hooked. You need to learn maybe that one really sick riff, that keeps you in it. And once you have that down, you're locked in. You're never going to put down the guitar. You're on your way. And so that kind of thing, I feel like it's very similar when you're learning a programming language like Elixir. So when you're coming in, you're really inspired. Maybe you've been to a conference. You've heard all these talks about these amazing things that you get with Elixir. Concurrency, fault tolerance, scalability. I mean, the hype list just goes on and on and on. But when you're first learning, when you're first starting out, that stuff is way far away, right? Like, you basically have to build an entire app and ship it to production before you get to enjoy any of those amazing features that, that got you in the first place. So what do you need to keep going? You need that really sick riff, right? So for me, and for a lot of the folks on our team, who are learning Elixir, that really cool riff was pattern matching. So to dive into it, to understand pattern matching in Elixir, you're going to want to start by reframing how you think about tying values to variables. So let's take this statement here. I'd say most folks, you'd probably read this as x equals 1, right? Where we're assigning the value of 1 to x, right? Well, not exactly in Elixir. And the biggest difference is this guy here, is what the equal sign is doing. So in Elixir, the equal sign is known as the match operator. And it's not assigning anything. What it's doing instead is it's acting as an evaluator. It's evaluating whether the value on the right matches the pattern on the left in both form and sequence. If it's a match and the variable's bindable, awesome, it's going to get bound. If it doesn't match, it's going to throw a match error. Those are your basics. So let's run through a couple examples just to illustrate things. So the one we were just looking at, so here's an example where we have a variable on the left, gets bound to the value on the right. That variable is going to match on anything, essentially, right? So this is going to bind every time. It's going to match. A slightly more interesting example, which, if you're coming from an object-oriented language like Ruby, like I was when I was first picking up Elixir, that the fact that both of these statements are, first of all, valid, and then also they're both matches, that was a head trip for me. That was totally wild. And so what's happening here is we have an example that makes it very clear, hopefully right away just from looking at it, that equal sign is not doing what you think it's typically doing, right, if you're coming from OO. It's definitely not assigning anything in that second statement. So again, we have our first one, it's bound. And then that second one, it's evaluating that match. So we have this integer that's going to match against that bound variable. It is a match. The integer is not available to be bound, and that's fine. And just matching and kind of carry on, right? So another example here, you can also rebind things fairly easily, arguably maybe too easily for anyone who's messed up a couple ecto queries like I have. So in this first one, we can bind it to 1. It's going to match again on that second one and get rebound to 2. And again, what's happening here is we're matching against form and sequence, not against the value. And so that's why the second one is a match. If you want to be a little stricter, you can use this character here, the little pin operator, this little caret. And what this does is it forces a very strict match against form, sequence, and value. So in this case, we have a pinned variable there with the second statement, and it is not available to be bound because we're enforcing a strict match, which again, so this guy's going to throw a match error. Let's look at some slightly more complex data structures. We can also pattern match with lists. These guys are fun. So again, matching on form and sequence, we have lists of equal amount of elements. So we're going to see these variables. Each one of them is going to get bound just right away, kind of a mass binding. One of the nicer, here's a little syntactic sugar that you get with lists. This is kind of a fun one that I like using. So you can use this little bar syntax here, where that first variable is head, and what that's going to match against, it's going to match against the very first element in that list on the right. And so that's going to capture whatever the first element is. And what you're going to get with tail, that's going to match with the remainder of the list. So this guy's really helpful, if you're kind of recursing over a really long list, you want to capture stuff kind of one by one, this syntax comes in handy. But one thing you want to watch out for is make sure that you're not trying to match against an empty list. There's nothing for that first variable to get bound against, so it's going to blow up on you. So just something to pay attention to if you're using that nice little bar syntax. Speaking of match errors, let's look at a couple more examples just to really drive the point home. So with this first example here, this is going to blow up because we have lists that don't have equal length. So again, that's going to throw a match error. Likewise, the elements inside of the list, every single element needs to match against each other. If it doesn't, it blows up. And also, again, we're seeing examples here of Elixir with that super handy error messaging. It's telling you exactly what you did wrong, which is just one of the nicer things throughout the entire language. More data structures. Let's look at tuples. You can match against these guys too. Very similar principle to what was happening with lists. And then with tuples, we start to see an example of what makes kind of mastering pattern matching, how this is going to come in handy as you're using everything throughout the language. So what will often, super common pattern that you'll see as you're working with Elixir is functions like decode, encode. You see this in the enumerable module. You see it with ecta. You see it with gen servers. These functions will return a tuple where the first element kind of gives you an atom, signifying status. Second one is something you can match against to kind of capture that message, right? So this is something that you'll see super common throughout the language where we're pattern matching against the return value here, and we can capture stuff for use later. So this is something that you'll see. This is just kind of ubiquitous throughout the language. And one last example that we'll look at is the underscore variable. So sometimes you want to match on stuff, but you don't really care about capturing the value. So for example, if we were looking at these kind of like status message tuples, maybe I just want to capture the message every time, and I really don't care about that first thing. You can use this underscore variable, which is a universal match. It'll match against absolutely everything. And so when you're using this guy, using the underscore variable, it sends a clear signal that you are not interested in capturing the value. Also, one thing to keep in mind, you really don't want to capture that value because it's going to get ignored by the compiler. So this thing just straight up is not going to get caught. A nice thing you can do, and one thing that your teammates and future you will appreciate, instead of just using the bare underscore, it's kind of helpful to name that variable so that you know exactly what you are actually ignoring. So you can kind of use the named underscore. And then what I was mentioning earlier, if you're using underscore, don't try to read from it. It's ignored by the compiler. It will blow up on you. So, all right. So those were some very exciting examples of the basics of pattern matching. You guys are all blown away, right? Loving it? Yeah, I can tell it. Riveted. Okay, cool. So you might be thinking to yourself, those were really fun, super academic exercises. How is this actually going to help me when I'm writing production code? So let's start to look at some more real-world examples. We'll see if we can impress you folks. Fingers crossed. All right, so wake up. All right, so this is an example. This is a screen grab from the platform that I work on all day, every day. This is learn.co. This is an example of a lesson page. Yes, it's very busy. Anyway, we'll just leave that as is. But this is a lesson page where our students, would be doing work and, yeah, just kind of learning all kinds of exciting new things like we all are today. And so the example that I'll use where pattern matching comes in handy is something that probably a lot of web developers in the room have had to solve, displaying friendly display names for your users. So with ours, our display names are built based on data that's been given to us by the users themselves. What makes it a fun challenge for our team in these following examples, the data that we use to construct these display names, we don't actually require the users to give us any of it. When they sign up, they don't have to give us any kind of friendly identifier. You don't have to give us a first name, last name, username, none of that. The only thing we ask for is an email, which is not something that you want to use as a friendly display name across your site. That would be, yeah, a bit of a privacy concern. So what we've had to do instead is when we're kind of putting those display names together, we've talked to products and came up with the following logic, for how we're going to put these things together. So we have a user record, no guarantee that it has the data that we need, so we have to run through the following logic checks. If it has a first and last name, fantastic, boom, that's what we're showing. If not, we'll check and see if there's a username. Great, if yes, we'll show that. And then if both of those aren't the case, we'll fall back to a friendly generic default. All right. So that's the logic that we had to put together. I actually was tasked with cleaning this up recently, and so I had some options. If I were to represent that logic in a language like, say, JavaScript, yeah, I might write something like this. And just to throw it out there, yes, these examples are terrible. I know that this is hideous JavaScript that would not pass code review. It's deliberately awful. I'm trying to make it look bad. It's for illustrative purposes, not code review. Please don't at me about these terrible examples. All right, great. So, but anyway, to drive the point home, we're seeing some ugly logic here, right? This is not a function that you can kind of grok in one glance. You kind of have to squint, dig through each of these conditionals. They're nested, so it's like a little higher complexity than necessary. It's not friendly, right? It's not ugly. This isn't something you want to look at all day. So not great. Maybe we'll turn to a different language. Let's turn to a developer-friendly language like Ruby that a lot of folks have come from. Again, another god-awful example, but driving the point home that this also not so great. Nested conditionals, this would never pass the Sandy Metz squint test. Not great, right? So this is shameless green with an emphasis on shameless. Okay, so those super common web development languages. Can Elixir help us? Can pattern matching make this better? Oh yeah, it totally can. So if I wanted to represent that same logic in Elixir, I might put together something like this. So what we're seeing here for folks who maybe are less familiar with Elixir, we've got multiple function heads. One of the cool things about Elixir, so when you define the same function with the same name multiple times, you're not overwriting the function. Instead, what you're putting together a multi-clause function. And so what Elixir does is when you actually call it, it's going to go to your module, it's going to find each of these function heads, it's going to evaluate each one, it's going to pattern match against the arguments that have been passed in, and when it finds a match on the arguments that you've defined, that's the one that will get run. So our examples here, we see that we've separated the logic out into 3 short and sweet, easy to grok function clauses. And so if we were calling each one of these, let's run through some examples. So let's say we have a user who's given us a little bit of friendly data. If we were to call this, it's going to go ahead and match on that second function clause because we have username. Someone who's given us slightly more information. We've got pretty much everything we need, so options are open. We're going to match on the first one this time, since we have those fields that we've defined there. And then finally, kind of a worst case scenario, we have a user who hasn't really provided anything. And so that's where we will hit kind of this catch-all at the bottom. That's our generic default, and life is sweet, right? This was fantastic. We've totally solved the problem. 3 function clauses. Thanks, Elixir. Good night, everybody, right? Well, almost. So, but hopefully what's being driven home here is that using these multi-clause functions, it allows us to kind of condense the logic, into its smallest, most atomic pieces. And all of it is encapsulated in an individual function. Very easy to read, super declarative. You've kind of self-documented what each one of these is doing just by dint of what arguments it's looking for. It's very easy to tell at a glance what each of these is doing. Again, one thing to keep in mind, order is important. So as I mentioned earlier, when we're evaluating these, it's going to run from the top of the file to the bottom, evaluating these in order. So you want to make sure that you put the most specific ones at the top. If you put something too generic at the top, that's going to match first on everything, right? The nice thing about Elixir, again, if you do something like this, it's going to catch it for you. It will throw an error and be like, hey, what's up? You've got you've got something that's way too broad at the top. You're going to want to move that down. So thank you, Elixir, and your awesome error messaging. So again, here's the side-by-side. Elixir versus Ruby. Elixir's a clear winner, right? Problem solved? Well, yeah, folks, you've probably noticed, as of yet, in our Elixir example, we haven't really solved for the thing that made our Ruby and JavaScript examples gross, right? Like, the gross part was kind of guarding against these nil values. And as of yet, our Elixir code is not doing that whatsoever. If we were going to run it as is, with a user who, the struct has those fields, but we don't have the values, we're going to show blank usernames pretty much everywhere, which is not ideal, not what we want. So how do we fix this? You might, first thing, if you're kind of new to the language like I was, you might think to yourself, you're like, okay, well, no big deal. I'll just throw a case statement in that first one, right? And I'll do a case, I'll protect against the nils, good times. But when you catch yourself doing this, and folks who have probably more experience with Elixir, don't be too fast to reach for those case statements, right? There are better options. I've heard Brooklyn's Linka kind of talk about the Elixir feel, and if you find yourself reaching for a case statement too soon, hopefully you'll catch yourself and just realize you're like, it doesn't feel quite right. So instead, you're thinking to yourself, you're like, all right, so it doesn't feel good. Maybe I'll just throw a bunch more function clauses at this thing. Let's multi-clause the heck out of this, right? Also shouldn't feel great. Hopefully you can see that this gets out of hand really fast. I mean, right now, for example, we're just kind of using 3 different fields, for building this thing. What if the requirements change? What if we have to start checking against a whole bunch of other fields? You can see how, this has the capacity to kind of, it's going to get out of hand super fast. So again, not quite right. So what's in our Elixir toolbox? What can we do to keep this thing a little nice and short and sweet? Elixir has some very nice guard clauses that can jump in and kind of save you here. And so, yeah, that's what happens when the fonts are off. So sorry, I'll post a deck with the boxes in the right place. No big deal. But anyway, what those are supposed to be highlighting is the guard clause here, which you can kind of tack on to the end there of your statement. These guys are really helpful. So they allow you to kind of augment your pattern matching with slightly more complex checks. You are limited to a predefined, kind of restricted list of expressions. They're all listed in the docs. It's the same as Erlang. The reason for this is that as we're running through and evaluating each of these clauses, we can't move on to the next one until we've finished evaluating each of the entire expression. And so if Elixir actually allowed you to kind of define, just throw like anything in there as your check, that has the potential to super big performance hit. It's not going to be efficient. And so what they're doing to bypass that is, look, you're just restricted. You're going to use only these allowed expressions that have already been signed off, optimized for efficiency. So yeah. So you've got a limited set of toolbox, but they're really helpful. For example, here, they protect us against nils. We're sitting pretty, right? Okay. So I will throw one more wrinkle into this, one more example. So let's say we've taken care of ourselves. Our code is looking good so far for protecting against nil values, but what about bad data? What if you had a sign-up page that looked exactly like our sign-up page? And what if maybe there weren't any validations on what the users were allowed to input here? and a bunch of bad data got into your system because a whole bunch of users put their email as their full name. Yes, this definitely happened. That's why I'm using this example. So how do we protect against this with Elixir? Because we really want to. The code as is written right now, it's going to match on that first one. And so we're going to be displaying a lot of emails all across the site. You guys remember how busy that lesson page was? Like just emails all over the place. All right, so what do? We definitely want to protect against this. So wait, so is now the time for a case statement? Who thinks we're going to use case statements? Maybe a conditional? No? A little cond? Okay, cool. You guys are with me. Awesome. So this is the last little nice bit of example for pattern matching tools that you can use. Elixir also allows you to define custom guard clauses. Now, before you get too excited, if you remember what I said before, again, you're going to be limited. That's what you can define these here. You're still going to be limited to that same, restricted list of super efficient expressions, but you can combine them to handle any number of, examples. You can combine them, to handle whatever business requirements have been thrown at you. So you can write these as a macro if you really like writing macros. What's recommended, though, is to write them as a proper guard clause. And so here, my workaround is just a very explicit check against the email. Not perfect, but it does solve this problem. And the reason that guards are recommended over macros is according to the docs. Using def guard here performs additional compile time checks. That sounds great, right? So once again, thanks Elixir. And if we look at our code now with our custom guard clause, we're in much better shape. So I kind of threw this example here at the top. Now if we have all these users who have entered bad data, when we go to display their name, safe and sound, not an issue, life is good. Thank you, Elixir. All right, so to kind of go ahead and sum things up, why master pattern matching in Elixir? Well, a lot of the things we talked about today, I think one of the biggest ones is in addition to making you a better Elixir program, it's just kind of programmer, it makes you a stronger programmer in general. So as we talked about, it's kind of nudging you towards best practices. So it's encouraging you to write these very small declarative functions. They do one thing only, so they follow that single responsibility principle. All of your functions are going to be self-documenting kind of by default, right? Like you're telling exactly what arguments you want to match against, so that's fantastic. So it's promoting really, really good habits, just in general. The other thing, in terms of why it's helpful for Elixir specifically, is as we kind of saw, the entire language feels like it's built around pattern matching, right? Like anytime you're calling a function, you're using pattern matching. It's running through those modules and matching against which clause is actually going to get executed. It's also a part of so many core libraries, like the ones I mentioned earlier. We've got enumerable, the base decode, encode, and you'll start using it when you kind of graduate to more complex systems, like when you start using everybody's favorite, gen servers. When you're making ecto change sets, you're going to see these patterns coming back. And so once you have those, pattern matching kind of mastered, you're in comfortable territory, right? So when you move on to the complex stuff, you're already feeling good, it's familiar, you're comfortable, you know how to use it. You basically have armed yourself with that really sick riff that we were talking about, and you are on your way to becoming the David Bowie of Elixir. So that's pretty impressive. All right, cool. That's it. Thanks, everybody.
Thank you. Thank you. Have we got any questions? Yeah? Gold mine of questions.
Hey, is it possible to write a test for a custom guard clause?
Sure is.
How would that look like?
I'll send it to you after the fact.
Right, thanks.
Sorry, very prepared.
Any other question?
What's the most common misunderstanding when people first learn pattern matching?
It's a great, very good question. One I feel as relative, someone who's learned it not that long ago, I feel well equipped to answer. Yeah, I think it's probably evident from what I just saw. Just not leveraging, the tools in the language itself. Like if I was talking to somebody about this earlier, when I look back at the Elixir code that I was writing for early projects, it was just Ruby. It was basically just object-oriented stuff, but like written in Elixir. And so instead of like using multi-clause stuff, I was using a whole bunch of case statements. I was using that logic like internally. I had really long, things. Like I was doing my error handling inside the methods instead of like matching against that with like helper clauses down the way. So I don't know. It's at least in my experience, someone coming from OO into functional, just not writing functional, Elixir, writing in an OO way, which is, yeah. It's not gonna do you any favors. You're missing out on all the stuff that makes it awesome. So.
Hi, I was wondering who can apply to Flatiron School. Is it more for teenagers or adults or?
That's a great question. Thank you for, what a great platform. Who can apply? Everyone. So we have students, as young as, high school. We have students, like there are multiple, we have retirees who are doing the program right now, which is awesome. I mean, it's retraining, right? Like they're done with whatever their first career was, they're ready to move on to something else. Yeah, anyone and everyone. So if you're excited, please apply. Also, while this question is open, our team is hiring and we write production Elixir code. So if anyone's excited about either being a student or working along folks who build the platform for students, talk to Flatiron School, get in touch. Thanks.
Thank you.
Awesome.
Thank you.
Thank you.